Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
And it's January.
Hello.
2019. 2018 was a good year.
2018 was an interesting year. No two ways about that.
It sure was. And, well, we have reflected on this before, so we won't go into that. Hey, I just want to tell you, in Better Know Framework, I had a really good experience last night at about 2 o'clock in the morning that I want to tell you about.
All right, here, roll it then.
Roll the music.
Hey, dude, what do you got?
Okay, well, charging for subscriptions with recurring payments and all of that stuff and invoicing is a lot of work.
Yeah.
If you've got an app, right, that you want to charge for access to on a subscription basis, and you have people that want to pay in different ways with different cards or PayPal or whatever.
Sure.
That's hard in and of itself, but then to set up something like a service that constantly rebills and deals with credit cards and emails people when their card doesn't work, like, that's a lot of work.
And you don't want to own any of that stuff, really.
Heck
right?
no.
And you've built a bunch of these things, so you know perfectly well you don't want to own any of this stuff.
Well, I've never built it. I've looked into what it takes to build it, and it's way too much work. It's not what you want to work on if you just have, a subscription podcast or some video or something like that you want to. Right. So there's a company out there. There's a bunch of people doing it out there, but there's one in particular that I found that was very easy to set up and very easy to just make work. And that's Zoho.
Oh, yeah.
Zoho.com. This is also show 1613. So if you go to 1613.pwop.me, P-W-O-P.me, you'll get there as well. And this is an entire turnkey service for subscription management with REST APIs and everything else. So basically how it works is you start with no money at all. You just create a test environment. And you create, a subscription, whatever it's called, and how much money and all that stuff. And you test it out with, they have the forms already there that you can embed in your web page or bring people to their web page or whatever. And once the subscriptions are in there, of course, there's a full back-end suite of managing customers and subscriptions and all that stuff if you want to do it manually. You can also not use their forms and just use their API if you want to do all the UI yourself.
Right, because you're a coding type.
Because you're a coding type. And then there's an API, you get all the keys and all the stuff that you need, but then there's an API to just simply get a customer by an ID, which you can relate in your database with a email address or whatever when you have a registered customer. And you can get back their status, whether they're active and all the information about their subscription. And it just works. It's just great. And they automatically send the invoices and do the recurring billing. And when cards expire, they let people know and you can see what their status is. All you really have to do is check the status and say, there's a problem with your card or the problem with your account, go here. Boom. And it's done. It's also pretty affordable. You can start for like $49 a month. And it gives you like 500 customers. 500 customers are buying a subscription. You could probably afford $50 a month.
Right.
And then for 2,000 customers, I think it goes up to $99 a month. 5,000 customers, $250, $249, something like that. So it's pretty good. It's not they're not nickeling and diming you. They're just charging you a flat fee per month, which I thought was good. And, their docs are great. Their videos are good. I just had a really good experience. And it was easy for me to integrate it into an app. So 3 o'clock this morning, I was like, yeah, Zoho.
Middle of the night successes.
Yep. Good job, guys. All right, Richard, who's talking to us?
Grabbed a comment off of show 1468, the one we did with Dina Goldstein back at NDC Oslo in 2017. And that was talking about event tracing for Windows, which turned into quite a long discussion about logging and debugging and so forth. Mm-hmm. And Eric Stendahl said this. He said, I think Richard touched on an important point. We as developers need to talk to the ops guys about logging. Too often I've seen and done logging that serves the purposes of the developer, but not the support staff.
We could actually start by talking to them about anything. Would be a good start.
Yep, that would be a good idea. How about that? Can I actually help you? It starts out as a debugging tool, but what mostly makes sense to the developer can be completely useless to ops. My company sells devices that run complex software, and our customer expects our product to just work, which of course it doesn't always do, because it's software. Mm-hmm. As we sell more devices, the support burden increases and it becomes more and more important to manage that efficiently. Since customers cannot be relied on to give useful advice besides, it doesn't work, you have a good story like that.
That's IJDW technology, right? It just doesn't work.
Right. It just doesn't work. The logs become a more important tool for our support staff to fix problems. Having good logs saves money. Are you writing support-friendly code?
Yeah.
And I know we're going to have a conversation today about debugging, challenging problems and understanding that. So maybe we're going to think even beyond the log.
Yeah.
So Per, thank you so much for your comment. A copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on Facebook. We publish every show there. And if you comment on Facebook and we read on the show, we'll send you a copy of Music to Code By.
And definitely follow us on Twitter. I'm at Carl Franklin. He's at Rich Campbell. Send us a tweet. Just works.
Just we log them.
Yeah, that's right.
Somebody invent traits for Windows.
Somebody logs them. I don't log them. Twitter logs them.
There you go.
And Music to Code By should be up to 19 tracks for $42 right now. As of
congratulations, brother.
Yep. Not yet as of this recording, but definitely. This recording was a month ago.
Right. So time shifting in the publication.
Yep. We'll see.
That's normal. We want Christmas off. We still want to give you great content through Christmas, but we like Christmas off.
We kind of do. All right.
Just saying.
Let's bring on Omer. Omer Raviv is creator and CTO of OzCode and an expert on Visual Studio debugging. Omer frequently speaks about developer productivity and software quality at conferences and .NET user groups around the world, encouraging developers to spend as little time as possible using the debugger and more time writing great software. Well said, Omer. I couldn't agree more.
Thanks. Great to be here.
Great to have you here. And, the term time travel debugging's been around for a couple of years, and everybody seems to have their flavor of it. What does that term mean to you?
Oh, that's a great question. So OzCode is a Visual Studio extension that, has a bunch of different features for better visualization and better code understanding. And we've just started dabbling in time travel debugging in our new version 4.0. I guess our flavor of time travel debugging is slightly different than the others you might have heard of, like, Visual Studio IntelliTrace and so forth, because most of those tools are talking about time travel to the past, whereas in OzCode, where we have a time travel machine that goes to the future.
We gotta go back!
Exactly.
Somebody's channeling his inner Doc Brown.
Pretty much.
What does that mean exactly, you travel to the future?
So you can imagine you're hitting a breakpoint at the very beginning of a method, and OzCode simulates execution of that entire method. And so instead of having to manually step through each line of code or having that experience we always get when you're like, you hit F10, 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 and then you're like, oh, damn, I hit F10 one too many times. Now I'm going to have to rerun this entire thing just to go back and see what happened there. So OzCode instead visually shows you what happened in the future. So it shows you how many iterations there were for each loop, how many if statements returned true or false. It sort of gives you a heads-up display for the debugger, so every expression that evaluated to true sort of lights up in green, and everything that's false lights up in red. And you can even choose a particular iteration of a loop, of a for each loop for that matter, and time travel to that moment in time, and OzCode will visually show you right on top of your code editor all the values of all the expressions in that particular iteration.
So in that case, aren't you essentially running the code?
So we're not running the code, we're virtually or simulating running your code. And that's actually a big issue in debugging, because if you actually run your code, which by the way, if you've ever gone into the watch window in Visual Studio or the immediate window and wrote out a method call and hit enter, that actually ran the code. And those are some of the biggest problems that novice developers run into when they're debugging, right? Because if you call a method in the watch window that changes the state of some static variable or calls out to the database, those side effects will actually happen, and then you get into the whole physics thing of the act of observing the program actually change the program, and now we're kind of in trouble. So OzCode doesn't actually run your code. It only simulates running your code in a separate sort of debugger voodoo magic virtual machine. And that's how we were able to give you this nice visualization. And I guess the big advantage of having a time travel debugger that goes to the future rather than the past is that you can do live coding. So you can edit your code while you're debugging with it and continue. But as with OzCode, as soon as you lift your fingers off the keyboard, OzCode will already show you how the future execution looks like with your changes. So we're trying to sort of blur the lines a little bit between coding and debugging by giving you a debugger that gives you instant feedback on every change that you make.
Now that just sounds like IntelliSense, right? Like when you're normally writing code in Visual Studio, you see the compiler running in the background all the time, showing you where you've made typos and what hasn't been qualified properly and so forth. I mean, what's the difference there?
Exactly. So essentially, we're trying to add another layer of information on top of IntelliSense, because IntelliSense gives you, static information about your code. These are the method calls that you can call on this expression. Whereas OzCode is showing you a runtime visualization, what the expression evaluated it to, how this code will execute, whether we're going to run into this if statement or we're not going to run into this if statement while you're actually doing breakpoint debugging. So essentially adding another layer of visualization that melds it in the actual execution of the code. And I guess one of the biggest and best bits of programming advice that my high school computer science teacher taught me is run it in your head first. Before you start the debugger, before you actually run it, make sure you actually run it. And that made me realize that there's a big cognitive dissonance between thinking about your code and the static nature of your code, the way you wrote it, and when you actually run it for the first time and see that nothing works the way you expected. And so that's why in OzCode we put a huge emphasis on visualization, a heads-up display for the debugger, so that after I wrote my code, I can actually see how it executed in a very intuitive way.
Now, the heads-up display, I guess, is only going to be really useful to me unless it's giving me some advice or some warnings or, some prescriptive, hey, don't do this because this is going to happen. I mean, if I just visualize the code running, sometimes I can miss a very important piece. So how do you guys go about calling to the programmer's attention something that they need to do differently?
So, for example, if you have a null reference exception, which I've never had before, but maybe you guys had one of those.
I'm having one right now.
We'll actually highlight in red the thing that's null, that's going to cause the exception, and we'll tell you in predictive analysis that a null reference exception is about to occur, so you can actually fix it before it actually happens. So we're sort of turning debugging into pre-bugging in a sense. We're showing you through a time travel machine that goes to the future what problems are going to happen. And that might be an exception. It just might be, an if statement that you expected to return true, but is actually returning false.
And that's based on the values that are coming in, right? I mean, it's not just the potential for a null reference, right? It's
right. You're actually going to have a null reference exception. Yeah, absolutely.
Yeah, I mean, that's amazing. I mean, you're basically taking what the compiler does and just making it that much more magical. Is that a good way to put it?
I think so. The big challenge for us in writing OzCode is that we're trying to take the semantic analysis and the syntax analysis and the working with syntax trees and a lot of expertise in using Roslyn for the understanding of how your code looks like, and sort of melding that in with a very deep understanding of the nuts and bolts of the runtime execution of your code we get through the debugger API, and blending those into a very nice visualization that helps you realize where you made mistakes in your code.
So many features. I mean, looking through all the things that this does. I'm just flabbergasted here and just, full stop here. I haven't used it yet, but I'm looking at the documentation and a whole bunch of the AppVNext guys use it and thought it was great. This is one of the reasons why we're having you on, because they're like, you got to get Omer on because this is like magic.
Sweet.
Switch statements, like you can see which case is going to hit. LINQ statements, because LINQ is really hard to debug, obviously.
Oh, yeah.
How on earth do you figure out what's going on in a LINQ statement?
Absolutely. I mean, in all my years of a .NET developer, I've always felt like when I'm using LINQ, I'm essentially making a sacrifice, right? Because if I write my code as a big chunky LINQ query instead of the equivalent, bunch of for each loops, procedural code, I get code that's a lot nicer to look at, and it's more readable, and it's more succinct, it's more functional and declarative. It's talking about what I want to accomplish rather than how I want to accomplish it, which to me is the essence of writing good, clean code. But at the same time, I'm essentially sacrificing debuggability for readability, right? If I step over a huge LINQ query in the debugger, it pretty much either finished or it threw an exception, but I have no idea what actually happened inside. So for me, LINQ debugging is perhaps my own personal favorite feature in OzCode, because what we try to do is we try to give you an experience where the more you use LINQ and the more functional, more beautiful style of C# programming, it will actually be easier to debug rather than harder. So one of the ways we do that is we actually give you these numeric indicators that show you how many items came from each part. So the select operator gave you 100 items, and after the where clause, we filtered it down to only 25 items, etc., etc. And then after you actually click a button, it actually blows up to show you a LINQ debugging visualization where you can go to any item in the LINQ pipeline and actually see visually how it passed through each operator, how it was transformed, and so forth.
Wow, that's
reminds
incredible.
me of a query by example tool. Same thing. You're writing a SQL statement outside of Visual Studio because you're trying to debug it, understand how it's going to behave before you embed it. So you just can't do that with LINQ. That sounds pretty cool.
Thank you. Yeah, for me, one of the things that warms my heart the most about LINQ debugging is that I'm actually seeing people use it as an educational tool. So a lot of people used to learn LINQ using the 101 LINQ samples documentation that Microsoft put out. And nowadays, if you Google visual LINQ lexicon, you'll see that a lot of people are using this fabulous article that some guy I never met on the internet wrote that actually teaches you what each LINQ operator does, and by you seeing the OzCode visualizations.
I always use LINQPad for that, but it's very much the query by example solution.
Mm-hmm. Absolutely. I'm also a big LINQPad fan. I think that's a very good recurring theme in good debugging and ad hoc programming tools is that you want that instant feedback. Coding is very different than pretty much all other creative activity. We often do a whole bunch of work, a whole bunch of thinking, and we really sort of logically think of every edge case, and only then we actually run the program and see what the actual code execution, the thing we're trying to achieve actually looks like. So any tool that brings me my feedback loop to be tighter and gives me faster feedback is a tool I want to have.
Very cool. All right, guys, hang on one second while we take a minute for this very important message. Hey, Carl here to say that Music to Code By is now an app called Music to Flow By. Now you can listen to the tracks on your phone with offline capability. The first 3 tracks are free, and the entire catalog is available by subscription with a new track arriving every month. Just go to musictoflowby.com for all the links. All right, and we're back. We're talking to Omer Raviv. We're talking about time travel debugging, traveling to the future, OzCode, and all the cool things it does. I'm curious about how OzCode enhances some of the debugging tools that we already have in Visual Studio. You are adding some new features, but you're also enhancing things like, well, let's just start with breakpoints.
Sure. So with breakpoints, OzCode gives you better ways to use trace points, for example. And for those of you who aren't familiar, trace points is a Visual Studio feature that's been there for decades. But when I talk about debugging around the world, I find that most people aren't familiar with it. So a trace point is just like a breakpoint, except every time we hit it, we don't break into the debugger. We just write some logging. And that makes it a really great tool for multi-threaded debugging, because if you try to debug a multi-threaded application the normal way you know how to debug, which is to just hit F10 and then F10, 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 that just breaks down, right? Because what will happen invariably in about 100% of the cases is that you'll hit F10 or F5 and suddenly you get an exception on a different thread. And then you'll hit F10 some more and you get a breakpoint on yet another thread. And it just quickly becomes a problem of trying to juggle too many balls in your head at once. So trace points is a great Visual Studio feature that allows you to add logging to your program while you're debugging it. And OzCode just gives you a much nicer editor for that and a fully featured log viewer to see those logs inside of Visual Studio in a much more convenient way. So in a lot of the features, we just embellish or complement what Visual Studio already gives you. Another example of that, I guess, is the data tips window, where if you hover over some variable and you look at a long list of customer objects for that matter, it's sometimes really hard to find what you're actually looking for, right? You end up spending a lot of time just peering through, trying to find this particular property or the particular field that matters to you. So we do a lot of work to allow you to customize the way an object looks like in the debugger with just a couple of clicks. Like I want to start this and this property, the first name and the last name and the ID are the ones I really care about. And then whenever you look at those objects again in the debugger, OzCode will remember that those are the fields and properties that are important to you. We also give you a very fast search feature. So we sort of, if you know what you're looking for, you know what it's called, or you know the value that you're looking for, we give you a Google-like experience to just instantly blaze through all different properties and find that one property that you were looking for.
I also like conditional breakpoints. Can you talk about that?
Absolutely. So when you're trying to, find a particular iteration of a loop where, the one iteration out of that 2,000 iterations that actually matters to you, what I sometimes found myself doing is just being an F10 monkey. I hit F10, 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 because I get a bit frustrated with the act of writing out a conditional breakpoint. I always get them wrong somehow. So OzCode has a way where you can from within the data tip window, when you're actually looking at an object, you can just do a few clicks on the fields and properties that you care about, and OzCode will write out the conditional breakpoint for you. So it's just a nice little touch to give you a faster way, a way to move faster.
Yeah. If I was in that situation, I would put an if statement, on the data. If customer ID equals 45,917, break, right? That's what I do. But it's a pain to do that.
It is often really much a pain. And it's the small things in debugging that we spend the most time on.
Yeah.
Trying to narrow down to the case that matters.
Exactly. And I think that to me, the real challenge in debugging is equal parts intellectual and psychological. So you're trying to reason about the program in a very rational, clear thinking way. But the thing is that when we're debugging, we're often trying to solve the same bug for an hour and yet another hour and yet another hour and sometimes days, and we keep failing at it. And that's where we sort of brush up against how we as humans deal with failure. To me, there's only two ways of using a debugger. One of them is a complete and utter waste of your time, and the other is what I call having quality time with the debugger. So, seeing that somebody is wasting their time using a debugger is really easy. If you walk past them, you just see them sort of staring blankly at the computer screen,
right,
and their finger keeps tapping that F10 button. And if you walk past, you realize that person has no idea what they're doing anymore. They're just really frustrated and they really want to go home. Whereas having quality time with the debugger is what I call applying the scientific method religiously. So if you make sure that by the time your finger goes for that F5 button, you already have a clear hypothesis in your head of what your theory is of why the code is not doing what you expected it to behave. And then you either prove or disprove that hypothesis and then move on to the next hypothesis. That's the only truly productive way to do debugging. It's just that as humans, we're fallible and we get really frustrated. And that's why I think that the power of being productive by knowing all the small nuts and bolts of the debugger is really, really powerful, because oftentimes that's the thing that makes the difference between narrowing down the root cause of a bug in just a matter of minutes rather than spending days on the same issue.
So you talked about null reference exceptions early on, and let's dig a little bit more into exceptions, because when an exception happens 13 levels deep, and then by the time you get to it, you've got this huge stack. And you have no idea, usually, sometimes you can look at that and say, oh, there's the root cause of that. But, a lot of times things happen that you don't really know by looking at the stack, right? How do you ameliorate that problem?
Right. And I think that what usually happens when you have that problem, for me at least, is that you click on that little button in Visual Studio that says View Details, and then you go to the inner exception, and the inner exception, and the inner exception.
Exactly.
And you try to find out the call stack, and then you probably copy paste that into Notepad just that you can find the line number where that original exception actually came from. So with OzCode, and this is the feature that, at conferences makes people gasp, is that we just take that away by giving you a single button that opens up the exception trail window, which just gives you a breadcrumb view into all the different inner exceptions. And then you can go through a fully interactive stack trace and click anywhere on it to see where the exception passed through. Though really, what you really care about in most cases is just you want to see the innermost frame of the innermost exception, right? You want to see where the exception came from originally. So we just added a button that does that. And that makes all the people clap.
Yeah.
We've also added a feature where you can, with just one button, go in Google or Stack Overflow, like a good developer would, of course, to see what that exception actually means. And because we've been showing that demo a lot in Microsoft conferences, we now have a fabulous new feature. You guessed it, Bing. So, don't worry. That we're very politically correct, and you can also search Bing.
I got to give Bing a little love here, because I don't think Google, and maybe I just can't find it, but Google doesn't have a way to sort by date the things that come back, and Bing does.
Oh, that's true, actually.
And I don't want to see a solution to a problem that somebody had that I'm having, and they had it 10 years ago. I want to see something in the last year. The only problem with Bing and that is that every time you change the query, what you're searching for, you also have to change it. The date doesn't stick. So Bing team, listen up. Make that date stick.
That default mode of always give me the latest stuff.
Exactly.
Yeah.
That's a good idea.
Anyway, that's Bing. Attaching to processes is something that is painful for me, usually, and I just don't do it. I usually find another way to, browsers especially, but usually find another way to attach to a process. What do you guys do to help that?
Well, we have a nice feature called Quick Attach, which basically allows you to very easily attach to the same. If you're constantly attaching to the same process, we'll just give you a list of here are the processes you probably are wanting to attach to. And if you're a keyboard guy like I am, we'll even give you an option to attach a shortcut to that particular process. So
nice.
I don't know. For me, I'm constantly attaching to Visual Studio, right? Because I'm constantly debugging a debugger that's sometimes debugging another debugger, because that's the story of my life. And so I have a shortcut in Quick Attach. Shift-Alt-1 will attach to devenv, to Visual Studio, so I can happily debug the debugger with just one keystroke.
Mm-hmm.
Hey, Omer, you want to give us a little bit of the backstory? Where did OzCode come from?
Sure. So it's actually an interesting story. I think OzCode was originally born on my very first job as a software engineer, where I was working in the medical imaging industry. So I was actually working on the software that the doctors and the technicians at the hospital all used to operate a CT scanner.
Wow.
And as a junior developer, I felt very anxious in that job. I was working on all these really complicated problems that had to do with the 3D box object that represents the space in the patient's body that we're going to be scanning. And we constantly had to move it from one coordinate system to the other. And one coordinate system had the y-axis going from head to toe, and another had it from shoulder to shoulder. And to make matters worse, every few months they used to actually take us out to the hospital, which was a beta site, to actually see how our code is being put to use. And I just remember that as being a very, very stressful experience, because I was sitting there sort of staring at what they were doing and thinking to myself, well, I really, really hope this thing doesn't crash, because if it does, and they have to deliver a double dosage of radiation to that patient over there, they're probably going to want a better answer than just null reference was not set to an instance of a variable. So that's essentially where OzCode was born. I kept feeling that I have to do too much work to appease the debugger in order to get the information out that I really want. And I wanted to make tools that will make debugging less threatening, both for experienced software developers, but also to other junior developers like myself at the time. And that's when I went to my boss and told him, that's it, I quit. I'm going to do my own thing, and we're going to start a startup for a Visual Studio extension.
What's the threat in debugging? I'm not disagreeing with you, but I'd love to hear you articulate why so many people find debugging so threatening.
That's a great question. I think part of it is simply the fact they never teach you debugging at school, right? They don't usually have a university course on debugging. And I think that's part of the reason. I think another part is that people in general, again, this all comes back to how we as humans deal with failure. When we're debugging, that inherently means that, there was a big problem. So we made a mistake. And so people don't like being in that position where they're constantly struggling to find an answer to why it's not working.
Right.
That's why I really encourage, I'm a big debuggers guy, and my go-to phrase is I always say you should find the techniques and the tools that allow you to spend as little time as possible using the debugger, and so that you have more time for, the fun parts of programming, the glamorous parts of programming, like crafting cool new features and refactoring and drinking coffee and all the good stuff.
Drinking coffee.
Or tea in your case, Mr. Campbell.
I'm drinking it right now. It's true. Very, very true.
So you guys have some new tools for Azure, right?
Right. So we're actually just announced a month ago that we have a new Azure DevOps extension. So we're trying to take OzCode from a debugging productivity tool into actually being a DevOps platform.
Nice. So what does that look like?
So essentially, we're trying to tackle the problem of production debugging, collaborative production debugging. So essentially, what the Azure DevOps extension allows is for you to do production debugging through your web browser. So you have a similar experience to debugging in your local IDE through your favorite web browser running out of your favorite operating system. We're leveraging the Monaco editor from Visual Studio Code. And we're trying to tackle some of the big problems that production debugging brings with it. First of all, production debugging is very costly, right? When you think about the cost of every software bug, when you find a bug that you just made a minute ago, okay, that has some cost, but it's pretty negligible. If QA engineer finds a problem and you have to fix it, that's slightly more costly because you have to ping pong with them and they have to verify that you actually fixed the thing. But of course, when we get into production debugging, that's when everybody feels like the whole building is burning and we have to fix it right now because customers are being dissatisfied with our product and we're potentially losing a lot of money. And production debugging has a lot of technical challenges too. So as someone who's done a lot of consulting in big, very successful enterprise companies, I've often seen that companies fail at production debugging at the very first step of figuring out, what are PDB files and given that I have a dump file, how do I even find a version of the source code that matches the binaries that were in production at the moment we failed and we got the dump file?
You got to be Tess Ferrandes to figure that stuff out.
Pretty much, yeah.
I'd also bring up the point that it used to be the only place you would do this is inside of Visual Studio,
right?
Which you need to pay for. Plus, maybe you have the OzCode plugin or any other number of things. Like, your ops guys don't have that stuff, and they don't want it.
Right.
Exactly. So we're trying to bridge the gap between dev and ops here, because we feel that having set up a CI/CD pipeline doesn't end when you have a big button that says deploy on it that actually deploys the software automatically. I mean, that's great, but when you actually hit that button, you're going to break things. You're going to bring some new bugs into production and going to cause some customers some pain because of that. So we're trying to add that aspect of production debugging into Azure DevOps, where for each deployment inside release management and for each separate environment, so QA, staging, production, you'll actually be able to see what are the new exceptions that occurred starting with this release, what are the exceptions that happened before and are still occurring in this release, and what are our regressions, what are the exceptions that have already supposedly been fixed because we have had a work item tracking them and we resolved it, but have somehow crept back into the system. And the main value proposition is just one click to debug. I want to have one click on a link that takes me to a fully featured debugger experience inside my browser, where I can hover over all the variables, see what everything was, figure out the bug, and even collaborate with my colleagues to talk to them about what I think is the root cause and gain a consensus about what the bug was, how we're going to fix it before we redeploy a new version of the software.
Right.
So essentially giving you the same experience of debugging through your local IDE, just inside of your web browser for the production issue.
And using the Monaco editor, like using all that web-based goodness that's platform independent and that anybody can use, like that the ops guys won't fuss too much about putting this on. It's not a big install.
Absolutely. It's just an Azure DevOps extension you get from the marketplace.
Mm-hmm, mm-hmm.
The other big issue that we are attempting to solve in production debugging is this whole notion of redaction of personally identifiable information. And that's becoming an increasingly big concern in today's world, where everyone's really stressed out about the very stringent regulatory and compliance constraints around data protection. So by just saying the word memory dump, I have a discount key with the memory dump that I got from the production environment. That implies that you have a file that contains a lot of potentially very sensitive information that's correlated to people's identities, email addresses, credit card numbers, social security numbers, phone numbers, et cetera, et cetera. So one of the key principles in our system is that we never allow you to actually download the memory dump into your computer and debug it for your local IDEs. We control everything you see through the web-based experience. And so an administrator has a full control of what personally identifiable information needs to be redacted. And they can also always go back and look at an audit trail of what information was exposed to a developer. So it allows you to do production debugging without being worried about staying compliant.
Not tripping over those PII problems.
Right.
Right.
But it's interesting to think about real-time redaction, that you're actually going to block out data that's personally identifiable in a stack trace.
Right. And that's a hard problem. So that's why we've worked very hard on this problem. We try to give you as much control as possible to actually be able to know what are the patterns, how is it redacting information, and be in full control over what was exposed and what was not.
I also like the idea of an audit log on that. I mean, even if you didn't redact it, that just you said this sort of casually, the fact that you know that this was the developer that was working in this area that may have been exposed to this data, so that if there is a breach of some kind, you might have some traceability there.
Right.
Absolutely. And I think it also gives you traceability in the sense that, we've integrated these web-based debugging experiences with the work items, Azure boards, so that when you have a work item that's covering a particular bug, that artifact of the fully interactive debugging experience plus the conversation, the collaborative conversation the team had at the time about what was the different potential root causes and how did we eventually fix it, is an artifact that you'll always have. And when the bug creeps back into the system a month from now, we'll be able to go back and see the actual debugging session and debug it once more.
Yeah. That's great. There's so many little features that we haven't talked about. Maybe we don't have time to talk about, but is there anything that you want to just throw out there that people may or may not know about?
Well, another feature that I feel strongly about is exporting, which is actually a unit testing feature. And I'm actually a big unit testing guy, and I'm also a big debuggers guy. And some people think that that's very paradoxical because a lot of the test-driven folks say that, debugging is an anti-pattern and you should never, ever use a debugger, only write a unit test. And I don't particularly subscribe to that theory, but I do absolutely think that you should indeed have a big, comprehensive testing suite in order to make sure that the time you do spend in the debugger is quality time. So once you understand the bug well enough, try to create a unit test or an integration test, or if you must, at least some throwaway console app that captures the problem, because then you've got the bug trapped in a room that has no doors and no windows, right? The bug has nowhere to go, and also you have that nice little added benefit that you have empowered your CI/CD pipeline with another regression test to make sure that the bug doesn't creep back into the system. So in OzCode, we have a feature called export, which basically allows you to take any object that you see in the debugger and create a textual representation of that object. And you can have that textual representation as either JSON, XML, or C# code. So imagine that I've been debugging the same issue for an hour now, and I try to put a breakpoint here, a breakpoint there, and finally I find that there's one particular customer object which causes the thing to break. So OzCode will let me essentially right-click that object that I see in my breakpoint debugging experience and generate C# code to sort of rehydrate that state, that data. And now all I need to do is copy that generated C# code into my unit test, and I can get up and running, converting the bug or reproducing the same bug inside of a unit test.
So, Omer, you said something before we started about an offer you wanted to give our listeners about OzCode.
Absolutely. So, as a tribute to .NET Rocks listener, we have a coupon code on the OzCode purchase page, which is .NET Rocks, and I will give you a 25% discount on your first year for your OzCode subscription.
Wow, is that DOTNETROCKS, or are you using the period?
Exactly, DOTNETROCKS.
Wow, that's awesome.
And what's the regular price for OzCode?
So it's for a corporate license, it's $175 per seat per year.
Okay.
But you get a bigger and bigger discount the more seats you buy.
What if you're just a lowly developer with a company of one?
So if you're a lowly developer and you're buying it from your own personal credit card, we have a personal subscription, which is just $99 a year.
That sounds too good to be true. Awesome. Thanks, Omer. This is great stuff.
Thanks so much. It's been a pleasure.
All right. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a